So good morning to all of you. In today's lecture, we are basically going to concentrate about the main topic, that is dispersion. How we are going to build the concept of a dispersion. What is the meaning of a dispersions? Apart from that, what are the different types of dispersions that are occurring in a multimode fiber as well as a single mode fiber. So we will see each and everything in details one by one. So first, let us try to build up about the definition of a dispersions. So in a very simple language, dispersion is called as a phenomena in which a spreading of a pulse take place as it moves from one medium, or it moves as it travels through the waveguides. So dispersion is basically a spreading of a pulse. So any phenomena in which the velocity of propagation of an electromagnetic wave is wavelength dependent, that is called as a dispersions. So we will first try to visualize it with the help of diagram, that when a pulse is traveling through a wave, when pulse is traveling through a mediums, how it look likes, and when your dispersion start building into the, or they are just getting into the more affecting the phenomena of the traveling of a pulse, how it look likes, and when your dispersion completely dominate the propagation of the pulse, then how your pulse look like in a waveguide medium. So we will see each and every things with the help of a small diagram. So let us first try to build a diagram. So in this, we are first taking the pulse shape on the y-axis, pulse shape or the amplitude of your wave, because it is basically the amplitude. If it decreases to a certain threshold voltage, your receiver won't able to recognize the correct signal distance along fiber. So let us first try to see it with the help of one figure. Like when your pulse is traveling through the fiber without having any effect of dispersion, how it look like. So we have two pulse that is propagating through the fiber. This is first pulse and this is second pulse. So apart from that, we have to first try to build a one threshold voltage also, so that your receiver could be easily able to discriminate between two pulses. So this is your threshold detection, threshold for detection of pulse. So in the first case, your two pulses are clearly distinguishable at the receiver. So at time, we are saying that at time t1, pulse are distinguishable. Now we are considering another time frame in which we are again going to consider the two pulses, and now here slowly and slowly your phenomena of dispersion is now building in the traveling of your signal. So again, this is the threshold detections. So as your strength of the two pulses are clearly below the point and they are having a manageable strength, so that they can be easily detected by the receiver. So that means at time t2, which is greater than t1, your pulse are distinguishable. Here it is clearly distinguishable and pulse are still distinguishable. Still distinguishable. Now the third case that we will consider is where your phenomena of dispersion is now surpassing the strength of the signal. So let's see it with the help of this figure, that is now. So in this figure, one can easily find that your strength of two signal is just touching the threshold voltage that can be detected by the receiver. So in this case, your dispersion is just about to surpass that secure level of the strength of a signals, which can be easily detected by the receiver. So here in the third case, it is barely two signals are distinguishable. So if we are considering a time where T3 is greater than T2, in that case, it is hardly to distinguish between these two pulse, barely distinguishable pulse. Now, another case, the last case in which we will see that it is impossible to detect or it is impossible to recognize the two different signals. This one, because as your threshold level is much below the strength of the signal, so it is not possible to distinguish these two signals when they are received at the receiver side. So we are considering another time, that is T4, which is greater than T3. So at this point, it is not possible to distinguish these two pulses clearly. So in this way, we can say how your dispersion phenomena is slowly building inside the waveguide. As if it is building inside the waveguide, definitely it going to spread the pulse that is transmitting through the waveguides. So when two pulses are we are not able to distinguish between these two pulses, then that phenomena is called as the inter-symbol interference, because these two pulses are not interfering in each other strength, and when they are interfering each other's, then definitely some values of signals will be lost. So that is called as a inter-symbol interference, and not possible to distinguish between pulse, or we can say that indistinguishable pulse. Better word is indistinguishable pulse. Indistinguishable pulse. And this is your inter-symbol interference. And this phenomena, that is this one and this one, region covering this one and this region are called as a inter-symbol interference. Inter-symbol interference. So this is the complete picture explaining how your dispersion is affecting the strength of the signals, and when it is affecting the strength of the signals to such a level that we are not able to distinguish between the two pulses, and if those two pulses they are interfering each other, such phenomena is called as a inter-symbol interference. So because of this inter-symbol interference, your pulse are interfering based upon the phenomena of the dispersions. So after building this concept about how your dispersion is occurring, how it look like when a two waves or two pulse are traveling through the waveguide, and what is the meaning of a dispersions, spreading of a pulse as it is traveling from inside the waveguide. So and this is the picture that is clearly depicting the how your dispersion is building inside the fiber. Now once we got this concept about the how dispersion look like, what is the definition of a dispersion, as well as how it affects the strength of the signals. Now next thing is that we should know about what are the different types of dispersions. So different types of dispersions, we are basically having three broad categories. First is called as intramodal dispersion, second is called as a intermodal dispersion, and third one is called as a polarization mode dispersions. So we will try to build the concept on each and every categories of the dispersions, how they are affecting a single mode fiber as well as the multi-mode fiber, which dispersion is not affecting which types of a fiber. So this one which we have already just discussed about what are the different types of dispersions, that is intramodal, intermodal and polarization mode dispersions. This intramodal dispersion is basically formed by a combination of two dispersion, that is a material dispersion as well as a waveguide dispersions. So we will see those things also when we go into details about the intramodal dispersion. Now this is the different concept of different types of dispersions, how your what is the definition in which you can define a intra or inter or a polarization mode dispersions. In case of intramodal dispersions, this is basically due to the result of a finite spectral width of the optical source. We are having an optical source, it could be a light, it could be a laser, or it could be a LED. So whenever we are launching a light inside the optical fiber, and if the spectral line width of the optical source is affecting the spreading of a pulse, that is known as the intramodal dispersion. So the intramodal dispersion is basically due to the finite line width of the optical source. Propagation delay between the different components or between the different frequency components of the transmitted light, because we have said that there is a finite line width of the optical source, and within that finite line width there will be a multiple frequency that will be included, and because of this multiple frequency there will be a delay between these two frequency which is propagating through the fiber, and because of this different speed or different velocity of a different frequency, they will arrive at the end of optical fiber at a different time. So if they arrive at a different time, so definitely there will be a spreading of a pulse. Such kind of a spreading or a broadening of a pulse is known as a intramodal dispersions. And the important point here is that it occurs in all type of a fiber, whether we are talking about the single mode fiber, multi-mode fiber, step index fiber, or a graded index fiber. In all types of fiber there will be a phenomena which is known, or there will be a dispersion which is called as a intramodal dispersion. So intramodal dispersion is basically because of the result of finite spectral line width of the optical source. So if it is a finite spectral line width, there will be a, within that line width there will be a multiple frequency, and if that multiple frequency they are traveling through the optical fiber, definitely they will be having a different velocity as they are facing the interfractive index of the core. So if they are having a different velocity, this leads to a spreading or a broadening of each transmitted mode, and they collectively form a phenomena which is known as a intramodal dispersion. The next thing is that about the intermodal dispersion. What is this intermodal dispersion? Now the main the criteria, the main point that is responsible for this intermodal dispersion is known as is the difference in the propagation delay between the various modes that is propagating through the fiber. And remember this, if we are talking about an intermodal dispersion, definitely it will be occurring inside the multimode fiber. Why? Because in case of a single mode fiber, your intramodal is basically intramodal dispersion is basically surpassing the other kind of dispersions. So intramodal, in single mode fiber, intramodal will be there, and in a multimode fiber we are having a intermodal dispersion, which is basically because of the difference in propagation delay between various propagation modes, and it is basically occurring inside the multimode fiber. So these different transmission time between the, as we have said, that different modes will be transmitted. So these different modes will be traveling at a different velocity. So if they are traveling at a different velocity, some might be traveling at a faster speed, some might be traveling at the slowest speed. So when they arrive at the end of an optical fiber, they are not arriving at the same time because they are traveling at a different speed. So if they are traveling at different speed, distance is same. Different speed leads to a different in the arrival time. So as a result, there will be a broadening of a pulse. Such type of a broadening of a pulse is called as a intermodal dispersion. Now, the last one is the polarization mode dispersions. So now this polarization mode dispersion is basically due to the variation in the fiber core diameter. Practically due to the variation in fiber core diameter, and especially in a single mode fiber, we know that if you're before that, if you're talking about the polarization, what is the meaning of a polarization? It is basically the orientation of an electric field of the light. The direction in which your electric field is oriented, we are saying that that is the polarization of a wave or a mode. So if you are talking about the polarization, we will concentrate upon the direction in which your electric field is oriented. So in this case, if you are talking about the fiber core diameter in a single mode fiber, we know that there are two orthogonally linearly polarized modes that are supported by the fiber. Now, due to this variation in the fiber core, due to the variation in the fiber core diameter, there may be, due to the presence of non-uniform stress or a bend along the fiber core, there will be a different orientation of this electric field. So if that different orientation, two orthogonally polarized wave is because of this stress or bending, they get slightly displaced. So if they are traveling along the fiber, so they will be arriving at the different time. So propagation time are different because of the difference in the group velocity among light rays, which give rise to a pulse broadening or a pulse dispersions. So these are the three different types of dispersion that is occurring in the fiber. So intramodal, intermodal and polarization mode dispersions. So if it is intermodal dispersion, it is basically occurring in the multimode fiber. If we were talking about the intramodal dispersions, so it is occurring in the single mode as well as in the multimode or in a step index or in the graded index. Everywhere you will be having a intramodal dispersions, and intramodal dispersion is basically a combination of two different dispersion, which is called as a waveguide dispersion as well as the material dispersions. So let us first try to build the concept of intramodal dispersions. So in the previous slide, we have discussed that as because of the finite spectral line width of the optical source, there will be different frequency component. These different frequency component, as they are traveling inside the fiber, they are facing a refractive index. So if they are having a different frequency, they will be traveling at different velocities. So if they are traveling at a different velocity, they might be arriving at the end of the optical fiber with a different at a different time, which leads to a spreading of the optical pulse. So this is which is written in this entire diagram, and is an entire paragraph. So it limits the transmission bandwidth of the optical fiber, your intramodal dispersions. So let us try to just find out some important points in this intramodal dispersion. So the important point here is your light source have a different wavelength because of the finite spectral width. So if they are having a different wavelength, they are facing a refractive index which is a function of a wavelength. So this clearly shows that the light of a different wavelength will travel along the fiber at a different velocity. Light of different wavelength travel along the fiber at different velocities. So they are arriving at the other end of the fiber at different times, which leads to a phenomena which is called as a intramodal dispersions. So we have discussed what is the concept of a intramodal dispersion. Now the next thing is, we have already discussed all these things. Let us first discuss about material dispersions. Your intramodal dispersion is a combination of material dispersion as well as the waveguide dispersion. So what is material dispersion? It can be considered as a spreading of the transmitted optical pulse through the optical fiber due to dispersion or due to dispersive property of the core, and it mainly occurring because of the result of a variation in the refractive index of the fiber core with respect to the operating wavelength, right? So it is basically because of the variation in refractive index of the fiber core with respect to the different wavelength that is traveling through the fiber, right? So if the spectral width of optical source is quite large, then the broadening of the transmitted optical pulse due to this effect may be significant, and this is called as a material dispersion. Now what is the formula which is telling you the mean, which is telling you the magnitude of the material dispersion is lambda by c mod of double differentiation of refractive index with respect to the wavelength. So if your dispersion is occurring because of the variation in a refractive index of the fiber core with respect to the operating wavelength of the light propagating through the fiber, then we say that the dispersion, such type of a dispersion, is called as a material dispersion. So the next thing is, this is the formula which is relating the material dispersion with the different parameters. Now where your d lambda is the material dispersions. So the spreading due to the material dispersion can be formalized as L sigma lambda into material dispersion. So one can easily find the material dispersion from this formula. Now the next thing is the waveguide dispersion. What is waveguide dispersion? So in the previous one, material dispersion, we saw that the variation in the refractive index of the fiber when a different wavelength is launched. So when a different wavelength is launched, they are facing a different refractive index. So if they are facing a different refractive index, they will be traveling with a different velocity. So if they are traveling with a different velocity, they will arrive at the end of the fiber with a different time frame, which leads to a spreading of a pulse. In the case of waveguide dispersions, so it is another form of dispersion which together form with the material dispersion, causing a intramodal dispersions. So your waveguide dispersion is occurring in a single mode fiber, and it is negligible or the magnitude of a waveguide dispersion is almost negligible in the case of a multimode fiber. So waveguide dispersion basically occurring because some part of a optical energy may propagate in the cladding rather than in the fiber core, and because of the fiber core and clad to have a different refractive index, the light propagate at different velocity into the core and the cladding. So in this we are assuming that the material dispersion, that there is no material dispersion in the fiber. So if we are having a fiber core as well as a fiber clad having a different refractive index, they do not vary with the lambda. So the time taken by the propagation mode to traverse the fiber length is represented by this is the formula that is representing the time taken by the different fiber modes, and here we assume that there is no material dispersion inside the optical fiber. So the different symbols that is representing here, this del is basically telling you the relative refractive index, which is equals to n1 minus n2 upon n1, or some formula can also say that n1 minus n2 upon n2. So the next thing is V. V is the normalized frequency. We know that it is 2 pi a n1 under root of 2 del upon lambda. And B is the normalized propagation constant within the fiber, which is related to the normalized frequency as well as the frequency of the operations. So this is about the waveguide dispersion as well as the material dispersions. Now in the next we will try to have the concept of a polarization mode dispersion. We will try to visualize it with the help of a diagram, and we will see what is mode, what is polarization mode, and what is polarization mode dispersion, what is the concept of a polarizations. So we will see all these concepts in our next class.